Imaginary numbers. These are the complex numbers. They are the numbers that when you have a negative under the square root, an I represents this number. That's the reason an I is never used as a variable when you're solving equations, at least not a lowercase I. What it represents is the square root of -1. Use an I to replace it. Just like a pi replaces 3.14, da 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 da. So a square root of -1 is I. And so there is a pattern for how I's work. If I raise that to the second power, if I square it, that cancels out the square root, and that gives me a -1. If I raise it to the third power, that's like me saying I have the square root of -1 times the square root of -1 squared. So this turns into a -1. So -1 times square root of -1 is -I. And then the last one is I have the square root of -1 to the fourth power. That's like me taking the square root of -1 and squaring it, and then multiplying it times the square root of -1. That's going to give me a -1 times -1, or a +1. And then the pattern will repeat. And we'll go back up to the I. -1, -I, 1. We will use this to help answer questions like the square root of a -36. Let me give myself some room to work. This is the same thing as the square root of -1 times a +36. So square root of -1 times the square root of 36. Square root of -1 is I. Square root of 36 is 6. So I times 6 is best written as 6I. So like I was showing you in the last one, there is a cycle to the I's. The best way to show this is in a little chart. These numbers are simultaneous. You can either have a 4 or a 0. So based upon the power on I, it tells you what the answer is. The answers are out in the green. The powers are in the white. So let's say I give you a problem like I to the 519th. We need to figure out how many times around that circle I went, and the best way to find out those groups is to divide it by 4, because that's a full cycle. So to 519 divided by 4, 4 will go into 5 one time evenly. I subtract and I get a 1. I drop down that 1. 4 will divide evenly into 11 twice, and that number would be 8. I subtract and I get a 3. Drop down the 9. 4 will divide evenly into 39 9 times. And 1 multiplied, that gives me 36. My remainder is 3. And so what that means is I look at my circle and I find the 3. And the green number is going to be my answer. So -I is my answer. This is as much work as you need to show me. You don't have to show me all the division, so if you do the division in your head, keep track of it in your head, that's fine. Show me at least this part. Now let's do another one. So 73, I need to see how many times we're going to divide by 4, because that's what a full cycle is. 4 divides into 73 once. And that gives me a 4, with a 3, and the 3 drops down. 4 divides into 33 8 times. My remainder is 1. So I look at my circle. where my remainder is 1. That means I'm up here. So my answer is just I. Y'all are going to do number 2 as the next problem in your notes. Let's look at another one. So this time, I have 52. I am going to divide that by 4. That will go in evenly 13 times with a remainder of 0. So that's here. But what's different is I have that 7 in the front. That 7 just gets brought down. And then I'm going to multiply it times what happens with my simplifying of my imaginary number. So that would be I to the 0, which was 1. So my final answer is 7. You're going to do number 4 in the next problem. The last type we're going to have is where you have to simplify the square roots. It's going to go back to what we did at the beginning of the year, or beginning of the semester. And so to simplify the square root, we need to take and bring out all the perfect squares, but also we're going to be bringing out this negative. That negative is going to come out as an I for the imaginary. Let's find out if there's any other perfect sets inside. So 450 divided by 2 gives us 225. We're going to divide that by 5, giving us 45. And we're going to divide that by 5, leaving us with 9. Divide that by 3, giving us 3. So I'm looking for what perfect sets do I have inside. I have a perfect set of 5s and I have a perfect set of 3s. So 5 times 3. Then that I, and then what's left behind is just that 2, so square root of 2. Simplifying what I have, I end up with 15 I square roots of 2 as my answer.